Hi everybody, Mrs. Pesic here. We are continuing our look at section 2.4 on complex numbers. And in this section, we're trying to find a pattern now. So what would be the pattern for this? Well, I, the first we know is just equal to I. And then I to the second, we already talked about that. That's going to be -1. But I to the third is going to be I squared times I to the first. So that's going to be a -1 times I. So that's going to be -I. What about I to the fourth? Well, I to the fourth could be thought of as I squared times I squared. That's going to be a -1 times a -1, which is a +1. So I to the fourth is actually just a fancy way of writing 1. I to the fifth would be like I to the fourth times I to the first. So that's going to be 1 times I. So that's just going to be I. And if you notice, the pattern is going to start to repeat here. So it's going to be -1 for I to the sixth. And then I to the seventh is going to be negative I. And I to the eighth is going to be 1. So it's going to keep repeating in that pattern. That pattern is I, -1, I, 1, and so on. So if I wanted to find, for example, I to the 37th, I could just say, hey, that's equal to I to the 36th, because that's a multiple of 4 for that exponent. And then times I to the first. So that would be 1 times I. So I to the 37th is really just equal to I. All right, so let's talk now about solving quadratic equations. Actually, let's talk very briefly about principal square roots. So principal square root, if a is a positive number, then the principal square root of the negative number, opposite of a, is defined as square root of -a is equal to square root of a times I. And we've done these. We've talked about these. Like if you want to simplify square root of -10, we would split that up into square root of -1 times square root of +10. So that's going to be I times square root of 10. All right, and so here, if I want to simplify this, I really have to think about square root of 3 as being I times square root of 3, and square root of 12 as being I times square root of +12, right? And so that gives me I squared times square root of 36. I squared is equal to -1, so I get -1 times square root of 36 is 6, so this is really equal to -6. So if you'd said, hey, I can do -3 times -12 and get square root of 36, but that gives me a +6, so that would be incorrect. So make sure you evaluate each one of these separately first. All right, so the answer to that one should be this, -6. So how about one more like that? Let's say we're going to do square root of -27. Remember, that's I times square root of +27, and square root of -6 is going to be I times the square root of 6. That gives me I squared now times 27 times 6. So if I'm going to do 27 times 6, that turns out to be 162. So square root of 162 then times I squared, but I squared is really -1. So I'm going to have opposite of the square root of 162. And I think that 81 goes into 162, so I can write this as negative square root of 81 times square root of 2. And so that turns out to be -9 times square root of 2 as our answer. Okay, so now let's talk about solving quadratic equations. You know how to do this already. So if I want to solve, this x squared plus 14x plus 9 equals 0, let's use quadratic formula to do this. So if I'm going to do that, remember quadratic formula is -b plus or minus square root of b squared minus 4ac. That's supposed to be a minus there. And then over 2a. Well, I can actually write it, each one of them over 2a like that instead of all over 2a. So my a is 8, b is 14, c is 9. So I'm going to get opposite of 14 over 2 times 8 plus or minus square root of b squared is going to be 14 squared minus 4 times 8 times 9, and that's over 2 times 8. And when I do this, I get negative 14 over 16, plus or minus 14 squared is equal to 196. So I get square root of 196 minus 4 times 8 times 9, which I'm doing on my calculator right now. 4 times 8 times 9 is 288. So I get minus 288 over 16. And so when we do this now, I can reduce this fraction to negative 7/8. And 196 minus 288 turns out to be negative 92 over 16. All right, and then can we simplify that further? Well, square root of negative 92, let's do that kind of off to the side here. I want to do square root of negative 92. I'm going to split that up into square root of negative 1 times square root of positive 92. Square root of negative 1 is equal to I. And figuring out the square root of 92, if I look for factors of 92, so if I pull up my calculator, I can get some little help here. So if I do calculator, I'm on a calculator page, and I do menu, and I do number, and I choose factor, I can say, oh, what are the factors of 92? And it tells me it's 2 squared times 23. So if I go back to my notes here, I can say that this is going to be square root of 2 squared, which is 4, times square root of 23. So I get I times 2 times square root of 23. So I'm going to get negative 7/8 plus or minus 2I times square root of 23 over 16. And then I can reduce the, let's see, I can reduce here, this 2 goes out with this 16. So 2 goes into 2 once and into 16 8 times. And let's see, just want to get rid of this little dot there. Okay, and then going back here, then we can say our answer is negative 7/8 plus or minus I rad 23 over 8. So we do have 2 solutions to this quadratic equation, but they are imaginary solutions. So let's talk about that for a minute. Let's get this calculator pulled up. So I'm going to add a graphs page. Do this with me, please. We're going to graph this function. Okay, and this function was, if I can remember what it is, I go back up to the top. If I was going to graph y equals 8x squared plus 14x plus 9, going back here, I'm going to type in 8x squared plus 14x plus 9. I think that's what we had here. Yep, 8x squared plus 14x plus 9. When we graph that and I enter it, what do you notice about the x-intercepts? Where does the graph cross the x-axis? Well, the answer is it doesn't cross the x-axis at all. It has no real solutions, but it does have 2 imaginary solutions. So if you graph a parabola and it does not cross through the x-axis at all, then that means you're going to have 2 imaginary solutions. If you have a graph that crosses through at, one place, let's do an example of that. If I say tab and let's say, oh boy, what's going on with my computer? Okay, I think I got that under control. So now if I want to graph something like x, okay, finally got that under control. So now if I wanted to graph something like x squared minus 6x plus 9, and I graph that, that graph is showing me that it is touching the x-axis in only one place. So there'd be one real repeated solution. And of course, if I type in another function, for example, let's just do something like x squared minus 25. Well, that is a parabola that is crossing through the x-axis in 2 places, and so that one has 2 real solutions. Let me make this like a, say -30 here, so we can see what's going on. Oh, it's not letting me do that. All right, so we can see it's crossing through, it's a parabola, it's crossing through in 2. But this picture back here was our graph when we got no real solutions. Instead, we got 2 imaginary solutions for this. All right, so let's take a look at another example. For this one, we're trying to solve this quadratic equation, 7x squared plus 5x equals -2. And so in this case, we are going to want to get everything over on one side. So let's add 2 to both sides. So I get 7x squared plus 5x plus 2 equals 0. That's supposed to be a 2. And again, I'm using quadratic formula. So I'm going to want -b over 2a plus or minus square root of b squared minus 4ac all over 2a. And so in this case, that's supposed to be an a. In this case, my a is 7, b is 5, c is 2. So I'm going to want opposite of 5 over 2 times 7 plus or minus square root of 5 squared minus 4 times 7 times 2 all over 2 times a. That's 2 times 7. So if I'm simplifying this, I'm going to get -5 over 14 plus or minus square root of 25 minus 4 times 7 times 2. I believe that's 8 times 7, so that's going to be 56 over 14. And if I do 25 minus 56, I am getting -31. So I'm getting -5 over 14 plus or minus square root of -31 all over 14. And we're going to simplify this radical with a negative and write this as -5 over 14 plus or minus I rad 31 over 14. All right. So I think that is the answer for this. These are the 2 solutions that are going to work. They are basically, -5 over 14 plus I rad 31 over 14 and -5 over 14 minus I rad 31 over 14. All right, and I think we're going to stop right there. Thank you so much for watching. Have a great day.